So now we've talked a little bit about what density is. We want to make sure that we can do some math problems with density. That's something you're going to need to be able to do on our upcoming quizzes and tests. We do a lot of this type of thing in chemistry, so it's important that right at the beginning we know a good method to solve these types of problems. So the first thing that we need to talk about is the equation. Our equation is D equals M over V. You won't be required to memorize this. We'll give it to you on the test, either on the back of your periodic table because it's there, or we may give it to you in the problem sometimes. But you'll always have this equation available. But if you want to memorize it, it might be convenient. Okay? The variables that you're going to talk about, that's what's represented by these letters, D, M, and V. The variables are called mass, volume, and density. All right, but what I want to make sure that you understand is that the units, the letters in the units, don't match up with the variables letters. There are some students that get confused about that, so let's make sure that we know what the units are and what they match up with. Grams are units of mass. Milliliters and centimeters are units of volume. And density units are grams per milliliter, or G/ml, and grams per cubic centimeter, which is G/cm cubed. Okay, so you've got your units down here as they relate to the variables up here. Okay, and we've got them kind of drawn out in columns, so hopefully that visually makes sense to you. But just keep in mind, M in the equation is going to be related to G in a problem because G stands for grams, and in the equation, M stands for mass. All right, this first one, 1.00 centimeters cubed. I just want to label these measurements as either density, mass, volume, or none of the above. It says neither, but none of the above is what we're talking about. So cm cubed is a measure of, well, let's see, cm cubed is right here. It's a measure of volume. You want to memorize these, though, not just looking up at this. You can do that at first, but I want you to get to know these in your mind so that you can read the problem quickly. Cm is centimeters. Centimeters is nowhere on here. It's a measure of distance or length. So we would say neither. And then I have 17.3 G. G stands for grams, which is a measure of mass. 36.4 ml. ml is a measure of volume. So let me put V. 29.1 grams per milliliter. That's density. It's just remember the density is the one that has the slash in it. It's the weird one that's a combined unit. It's got two different units combined. Okay, so this is density. Sometimes I write it as uppercase, sometimes lowercase, and I don't care what you do for density. 13.6 grams per milliliter, again, density. And then I have 13.6 meters cubed. Now that one's not listed here, but I see that centimeters cubed is volume. I can probably assume that meters cubed is also volume. So that is a unit of V, or volume, just not one we use very often. And then again, kilogram, remember in the metric system, we learned you can put prefixes before these things. So kilogram would be another example of mass. All right, that's it for how to label variables. Now let's see if we can learn a little bit about how to calculate density. Now in a lab, you can't just measure something on a density meter or something. You actually have to measure two different things because remember, it's mass divided by volume. So I have to measure the mass using a balance, and then collecting volume, there's a few different ways to do it. But we need to have the mass and the volume to solve a problem. Now let's talk about how we do that. To take the mass of a liquid, a lot of times what we'll do is we'll measure out the amount of liquid in a graduated cylinder. The volume can be determined directly just by reading the volume. Okay? But when we go to find the mass of it, we use a balance to mass the empty container. Then we add the amount of liquid that we want, the volume of liquid that we want, and we mass it again. And the difference of those two amounts will give us the mass of the liquid. That's how you're going to find the density, is by doing the difference. You find the mass of the liquid and then divide it by whatever volume you find. Now, if it's a solid, not a liquid, there's two ways that we might find its volume. One way is if it's a regular solid, like a regular shape, a rectangular prism or a cube or something of that sort. We can do length times width times height. Length times width times height. And you probably learned that in geometry. With a ruler, or in algebra maybe. So with a ruler measurement, you can measure each side and multiply them. But if it's an irregular solid, there's something we call water displacement that we use. And I want you to understand this. You're probably going to see some questions like this on the interim and on other quizzes and tests. There's an example right here. I have this little toy alien guy, and I've got a certain amount of water in this graduated cylinder. Then I dropped him in, and when I dropped him in, the water level went up. So if I want to know the volume of this irregularly shaped object, or if I were doing the same thing with a bolt or a screw, and I want to know its volume, I drop it in water and I see how much it rises. So in other words, the volume of the object is the final volume of the water minus the initial volume of the water. So in this case, I'm looking at this. It looks like this is about 5.0, I would say. 5.00 milliliters minus, and this looks like 3.200. Actually, that's not right. This is because these are going up by 2. So this would be 3.400 or 0.40, 3.40 milliliters. And when I subtract that, to do it in my head, but I could subtract that, 5.00 minus 3.40, and you're going to get 1.6 in your calculator. Don't forget, you've got to add that extra 0 to keep our sig figs the same. 1.60 milliliters. That's it for finding the volume of the irregular object, and then you would find the mass by putting it on a scale. Then we could solve the problem. All right, here's a concept question for you. A solid object is dropped in the column. So this is a column, the density column. It settles between liquids C and D. So we've got this black object right here that was dropped in, and it settled right between C and D. Here's what we want to know. What liquids are more dense than the object? Now remember, if it's less dense, where does it go? It floats. It goes to the top if it's less dense. And if it's more dense, it goes to the bottom. So we've got all these different densities. The liquids that are more dense than the object are C, B, and A, or we could put it in alphabetical order. A, B, and C. What liquids are less dense than the object? Well, 3 and 2 seem to be, so D and E. Because they're above that object. estimate the density of the solid object. It's probably going to be between the two that it fell between. So it's somewhere between 3 and 5. You could say maybe it's about 4. If you said it's about 3.5 or something like that, that's fine too. We just know it's probably between 3 and 5. All right, moving on to the next page. This is where we get into some example problems. And it's very important that you set the problem up correctly. So, I want you to try to use some annotation techniques on these problems. At least the first couple. First thing we want to do is identify all of the data that looks like it could be important. So I see this, a cube with sides of 2.50 centimeters. I'm going to draw boxes around my data. It has a mass of 15.0 grams. I need to be able to calculate the density of the cube. And then I also need to answer the question, would this cube float or sink in water? And it gives me the density of water. Okay, let's talk about the strategy for at least that last part. Will it float or sink in water? Well, if it's less dense than water, so if it's less dense than 1.00, it would float. If it's more dense than 1.00, it will sink. That's how we're going to answer that part. But before I can answer that, I've got to figure out the density of the cube. So, if I want to find density, we need to know our formula. The formula is D equals M over V. Again, you don't need to memorize it, but you need to look at it and know how to use it. D equals M over V. In this class, I want you to always label your variables and then set up the equation. So I see 3 variables, density, mass, and volume. I'm going to write those over here on the left side, D, M, and V. The way you tell which is which is by looking at the units. We know that grams are a unit of mass, so I'm going to write that down, 15.00. And I'm going to include those units because they become very important. I've been asked to calculate the density, so I know that's what I'm looking for. Whatever I'm looking for, I'm going to put a question mark by it. Calculate the density. I don't know what that is yet. And now I need to find the volume. Is 2.50 centimeters a volume unit? I hope you recognize it's not, but it will help us to find the volume. It says it's a cube with sides of 2.50 centimeters, and the volume of a cube is each side being multiplied. Okay, so length times width times height. With a cube, all of those are the same. So the volume will be 2.50 times 2.50 times 2.50. Or you could say 2.50 cubed. That would work as well. To the third power. 15.625, but I want to follow my sig figs and say 15.6. 3 sig figs, 15.6 centimeters times centimeters times centimeters would be centimeters cubed. Just like x times x times x is x cubed, centimeters times centimeters times centimeters is centimeters cubed. I'm going to draw a line right here, and then I will solve my problem on the other side of the line. I have mass, I have volume, so to find density, I just plug it in, and I do mass divided by volume. When you put that in a calculator, you get this long number, and I need to round to the lower number of sig figs. This is 4 sig figs. This is 3, so I need to round to 3 sig figs. That would be 0.962 because that one will round up. And then we need to write units. This is the part where you need to think about what we just did. We divided grams, divided by centimeters cubed. So that's our units, grams per centimeter cubed. All right, this problem is a lot more involved than some of the density problems. There's a couple things that make this a little more complicated than your typical problem. One of them, I asked you to find the volume. You won't always have to do that. Sometimes the volume is given to you. Another thing is I gave you the density of water and asked if it's going to float or sink in water. So now we've got to compare that. Water's got a density of 1.00 grams per centimeter cubed, and this is 0.962 grams per centimeter cubed, which is less than water, so it would float. So you want to write that down. It would float in water because it's less dense. All right, there are some of these problems, like I said, that are more simple, and some are maybe just a little bit different. I'm going to go ahead and stop here. I recommend that you try each problem first, and then watch the video, or at least look at the solution to see if you get the same answer. And if not, then you really want to slow down and see where you went wrong.